Okay, part three of my little three-part series here. So for molecules, we're going to have conformational changes. We should all know what these are. They're just basically reworking the order of the molecules. So I mean, you got a 5 carbon here, you got a 5 carbon here. They're the exact same molecule. You didn't have to break any bonds. You didn't have to move anything around. They're just oriented differently. So see if you can kind of like switch them around in your head. If it makes sense, cool. The other thing that you can do that Peter suggested is you can do the IUPAC. So the IUPAC for this is exactly the same as the IUPAC for that, but that's a longer step. Just see if you can kind of rotate it in your head and make them equal each other. Then you have different or unrelated. So different or unrelated are going to have a different chemical formula. For instance, CnH2n plus 2 or CnH2n or whatever the formula is. They're going to have different formulas. At that point, they're no longer isomers or conformational changes. And then you have isomers. Isomers are always going to have the exact same CnH2n plus 2 or CnH2n or whatever it might be, right? Those are always going to be exactly the same. It's just that the name is going to be different because things are oriented differently. So an example, there's 3 different main types that we need to know, and then there's a 4th which might be on the test a couple times. So let me see. Structural, constitutional. Okay, so we've got structural, which is also called constitutional. They mean exactly the same thing. This is subdivided into 3 categories. And then you also have stereoisomers. Now stereoisomers are just going to be cis and trans. So cis and trans is really easy. You're only going to get cis and trans in the scenarios that we've been working on if you're dealing with a double bond. So that's, C, C. You're going to have something going up and down, and you're basically going to determine what cis or trans is based on the priority of whatever molecule you're dealing with. So like carbon has a higher priority than hydrogen. So in this situation, you would say that the carbons are higher priority. So they're going to be cis. They're on the same side of the molecule. If this carbon was up here, they'd be trans because they're across from each other. But let's say that you've got an OH instead, an OH and OH, and a carbon and a carbon. The OHs have higher priority. So you're going to want to label it as cis or trans with the OH because OH is going to determine it as an alcohol. So that's one way to do it. Another way is that if you have a cycloalkane or alkene or alkyne or whatever, and you have molecules coming off like this, you might also have them going on the inside. So this would be cis-trans. This would be cis, this would be trans. So that's the only other way that you're going to see it. You might see that on the test, but it's more likely that you're going to see this formula. So you just have to remember double bonds give that kink, and that's going to mess things up. Structural and constitutional, which again are the same thing, those are going to be subdivided again into 3 categories. So you've got, I'm going to do this on another page. So structural. So you're going to have skeletal, which we should know at this point is just basically moving your carbons, right? So if we've got carbon, 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 a structural or skeletal isomer might be carbon, 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 carbon. You cannot conformationally rotate these so that they're the same thing. You have to break a bond. So this bond has been broken and moved over here. So that's a skeletal change. Let's go over to a positional change. Now, positional is going to be moving the functional group. So it's not really going to matter with alkanes, but it will matter with things with double bonds, things with triple bonds. It's also going to matter for things with alcohols and stuff like that. I'm going to use alcohol as an example, but basically positional is always moving the functional group, whatever has the highest priority. So let's say we have a C, 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 and we have an OH. If we move this OH over to here, so let's say we get rid of it from there and we move it here, That's a positional change because we basically move the functional group, which is the OH. The final one, and this gets kind of confusing because positional is moving the functional group, but there's one other one which is actually called functional isomer. And a functional isomer means that you're basically fundamentally changing what the molecule is going to do. So the only example that we're really going to do in this class is going to be with ethers. So if you have a C, C, O, C, 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 versus, C, 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 and OH, technically you have the same molecules here. You have 6 carbons and you have an oxygen. But with this guy here, this oxygen is bound to a hydrogen. This is going to have hydrogen bonds. It's an alcohol. This is going to react. It's going to be polar. It's going to be very water soluble. Then you've got this down here. It's got the same basic chemical formula, but what's different about it is that this oxygen has its octet filled. So it's got the bond here and the bond here. And what that means for this molecule is that this oxygen is basically going to react as if it's just another carbon in the chain. It doesn't have any hydrogen bonding to it, so it's not going to hydrogen bond. It's not polar. So basically the functional group has been disabled, which is this oxygen here. So they are isomers of each other, but they're functionally different. And that's basically the main thing that you need to know about isomers. So just stereoisomers. The one thing about stereoisomers is basically when you're naming them, like let's say this molecule right here, I got 4 carbons, so C, double bond, C. So this is going to be a butene. Butene. And it's on 2, so it's a 2-butene. If we draw this out, still 2-butene, but basically what we're doing with this, because we've drawn it out in its proper format and we got the carbon on the bottom and the bottom, this is basically going to be a 2-butene. And you're just going to write cis or trans at the start. So cis 2-butene. So if they ask for an example of how to name it, that would be it. You just add a cis at the front or a trans at the front. And that's it.